Now consider an example like this. Now say that you have been given something like this. X squared, right? X squared plus 2x plus 5 plus 2x plus 5 over x plus 2 times x plus 3 times x minus 1. X plus 2 times x plus 3 times x minus 1. So if you have been given something like this, how to divide this into its, how to dissociate it into partial fractions. Now first of all, you need to understand that the powers between the difference of powers between the numerator and the denominator. Now the highest power of the numerator is 2 and the highest power of the denominator is 3, because now you can see that when you multiply these three terms, you will get an x cube here. So when you get an x cube, you will get the highest power of the denominator as 3, and since there is a quadratic equation, quadratic expression, you have the highest power of the numerator to be 2. So the difference of powers between the numerator and denominator is 2 minus 3, which is minus 1. So actually you can write a function in which the highest power is minus 1, because functions are defined to be starting from constants where the highest power is 0. So actually you can write powers where the highest power is minus 1. So you can write a function. So to divide this into its partial fractions, what you do is just to take it into its factors. Alright, so let's take it. So I'll write it again, x squared, right, squared plus 2x plus 5 over x plus 2 times x plus 3 times x minus 1, right? So this is the thing you have been given. So since you can write fractions, since you can write linear or quadratic equations, you have to first of all divide this into its fractions. So it will be a divided by, I'll take it as a divided by x plus 2 plus b divided by x plus 3 plus c divided by x minus 1, right? B divided by x plus 2 and x plus 3 and c divided by x minus 1. So now what you have to do here as the second step is that you have to multiply both sides by the denominator of this fraction, by the denominator of this fraction. So the denominator is x plus 2 times x plus 3 times x minus 1. So what you have to do here is that you have to multiply both sides by x plus 2 times x plus 3 times x minus 1. So when you multiply the numerator by x plus 2 times x plus 3 times x minus 1, which is the denominator of that fraction, you are left with the numerator, because this denominator and the fraction that and the terms that you are multiplying here will cancel off, and your the remainder will be the numerator. So you will remain in the numerator is x squared plus 2x plus 5, and that's equal to, sometimes in some books and some websites you may have seen that there's an identical sign here. That's because this identical sign, now I have written here an equal sign, but sometimes it's an identical sign is used because we actually expect that both sides to be completely identical, that both sides are the same for all functions. That's what I mean with that, for all characteristics, for coefficients, for behavior of functions, for the graphs of functions, everything, the left and right sides are completely equal. That's why we say identical. But over the years, the identical sign has been replaced by equal sign. So I will also use the modern equal sign here. You can also use the identical sign, it's no problem, right? So here, in the right side, when you multiply by x plus 2 times x plus 3 times x minus 1, and when you multiply this term, so this is one term, this is another term, This is another term, right? So when you multiply this side by x plus 2 times x plus 3 times x minus 1, this x plus 2 and this multiplying x plus 2 will cancel off, and your the remainder will be x plus 3 times x minus 1, and we have to multiply that by a. So our first term on the right side will be a times x plus 3 times x minus 1, right, x minus 1, plus b times, now when you multiply b, this x plus 3 and this x plus 3 will cancel off, so you remain with x plus 2 and x minus 1, so x plus 2 times x minus 1, so you have to multiply b by x plus 2 times x minus 1, 2 times x minus 1 plus c. When you multiply c, you know that the denominator is x minus 1, so here you already have x minus 1, so that x minus 1 and this x minus 1 will cancel off, so the remainder will be x plus 2 times x plus 3. So you have to multiply c by x plus 2 times x plus 3. So x plus 2, right, x plus 2 times x plus 3, right, x plus 2 times x plus 3. So what you do as the third step of this equation, as the third step of this solving into partial fractions, is that you have to equate the so first of all I'll take this one to be equation number 1. As the third step what you have to do here is that you have to equate the coefficients of each terms and find the values of a, b and c. So you can write a as x plus 3 times x minus 1 is equal to x squared plus x squared plus 2x minus 3, and b as x squared plus x minus 2, and c as x squared plus 5x plus 6. So you can write like that, and you can easily substitute the values, actually equate the coefficients and find the values of a, b and c. So I think you can directly from here, I can see that you can directly find the values of a, b and c. You will have to go to several equations. So let's find out. So by equating the coefficients of x squareds of both sides, what I can get is that the coefficient of x squared on the left side is 1, and on the right side when I multiply a by x times x, I will get x squared here, so the coefficient of x squared here will be a, and here you get a plus sign, so you have to add this, and when I multiply b by x times x, I will get another x squared, and the coefficient of that x squared will be b, so plus b, and here is again a plus, you have to add this, and when I multiply c by x times x, this term is x plus 2 and this term is x plus 3, so when I multiply this x and this x, I'll get an x squared, so and that x squared should be multiplied by c, so the coefficient of x squared here is c, and so our second equation is a plus b plus c is equal to 1. So that's one. The next step will be to equate the x's, right? So when you equate the x's, you can say that the x term here is equal to 2, and that's equal to, when I multiply this one by this one, so I'll get an x squared minus x plus 3x is plus 2x, so I'll get 2x here, and I have to multiply that 2x by a, so my term in this side will be 2ax, so the coefficient of x is 2a. Now don't wait for the plus sign here, don't wait for the plus signs, because sometimes this term, when I get the x's here, sometimes I'll get this as minus. So let's first of all know whether the coefficient of x is minus or plus, and then finally select whether we have to add or subtract. So when I multiply x plus 2 by x minus 1, what I'll get is x squared plus x minus 2. So I'll get plus x here, and that plus x is multiplied by this plus b, so that will be plus b times plus x, which is plus bx. So my coefficient of x is plus b, so I add b here, plus when I multiply c by these two, so x plus 2 times x plus 3 will give me x square plus 5x plus 6. So the value of the coefficient of x is 5c, and that's a positive one. So we have to add this. So we have to add this positive 5c, and that will be my equation number 3, right? That will be my equation number 3. So the only option left for me is to equate the constants. So when I equate the constants, I get I have a plus 5 here, so my left hand side would be plus 5, and on my right hand side I have 3 times minus 1, which is minus 3, and I have to multiply that by a, so that will be minus 3a. So the coefficient of the constant is minus 3a. So I will get in minus 3a. So when I multiply this 2 by this minus 1, I will get minus 2, and I have to multiply that minus 2 with this plus b, so that will be minus 2b. So the coefficient is minus 2b. Similarly, when I multiply this c by 2 and this plus positive 3, I will get here positive 6, and I have to multiply that positive 6 by here positive c, so that will be positive 6c. So I have to add 6c again here, 6c. So this will be my equation number 4. So those are the only options that I am left with. So what I will do is that I have 3 unknown terms and 3 equations, so I can solve this. But the only problem is how to solve this. Now first of all, you need to know that you have minus 2b here. So first of all, what you can do is that you can add these two equations and get positive 2b, and add the final equation that you get from these additions to this equation, so that that positive 2b and this minus 2b will cancel off, and you are left with an equation containing a and c. So my first equation will be, first step will be to add 2 and 3. 2 and 3. When I add 2 and 3, I have 1 plus 2, which is 3 on the left side, and a plus 2a is 3a, b plus b is 2b, and c plus 5c is 6c. So that I will take as equation number 5, right? Equation number 5. So we have my fifth equation is 3 equals 3a plus 2b plus 6c. So that's my fifth equation. And as my fourth equation, I have 5 equals minus 3a minus 2b plus 6c. So that's my fourth equation. So when I add up 5 and 4, this plus 3a and this minus 3a, this plus 3 and minus 3 will cancel off. This 2b and minus 2b will cancel off. So 3 plus 5 will be 8. And 6 plus 6 is 12. So here I will get 12c. Furthermore, I can simplify this both sides by dividing by 4. So 4 times 8 is 4 times 2. 12 is 4 times 3. So I will get the value of c to be 2 upon 3. Right? The value of c to be 2 upon 3. Now since I got the value of c, my next step would be to find the values of a and b. So to find the values of a and b, I can easily substitute the value of c to equation number 2. From equation number 2, I can say that a plus b plus c is equal to 1. So since a plus b plus c is equal to 1, 1 is equal to a plus b plus c is 2/3. So that will be 2 by 3. So a plus b will be equal to 1/3. So a plus b is equal to 1/3. I take this to be equation number 6. And from equation number 3, I can say that 2 is equal to 2a plus b plus 5c. So c is 2 by 3, so 5c will be 5 times 2 by 3, which is 10 by 3. So when I take it to this side, that will be 2 minus 10 by 3, which is 6 minus 10, so that will be minus 4 by 3. So minus 4 by 3 is equal to, 2a plus b, 2a plus b is so I can write, I don't need to make this an equation. What I'll do is that I'll write 2a as a plus a, so it will be a plus, I'll take a plus b inside the bracket is equal to minus 4 by 3. So from equation number 6 I already know the value of a plus b to be 1/3, so I can substitute that here. So when I take 1/3 here, that will be a plus 1/3 will be equal to minus 4 by 3. So when I take this 1/3 into this side, it will be minus 4 by 3 minus 1 by 3, which is minus 5 by 3. So a will be equal to minus 5 by 3. So since a plus b is equal to 1 by 1/3, b will be equal to now 2, right? B will be equal to 2. So a, b and c were actually the values that were taken by me. So the question is asking about what are the partial fractions when you divide that fraction, this fraction at the beginning. So the a, b, c were arbitrary values that were taken by me. So I had substituted the values of a, b and c to find the final answer. So the partial fractions, right? The partial fractions would be, so the given function is x squared plus 2x plus 5 divided by x plus 2 times x plus 3 times x minus 1. So that is equal to, right? So that is equal to, so you can say that is equal to a divided by x plus 2. So a is equal to minus 5 by 3. So that will be minus 5 over 3 times x plus 2 plus b divided by x plus 3. So b is equal to 2. So that will be 2 divided by x plus 3 plus c divided by x minus 1. So c is equal to 2 by 3. We found that. So that is equal to plus 2 divided by 3 times x minus 1. So this is the final answer that they are expecting as the partial fractions of this whole fraction. So in this video I introduced you about the partial fractions and gave you a simple example. So in the next video and the videos hereafter on the series of videos on partial fractions, I will be explaining you with some complex examples and different examples, different formats for which we can easily find the partial fractions. So thanks for watching this video and see you then.